Hidden within the DNA of the Berbers is a story older than civilization itself. A story of survival, adaptation, and an unbroken lineage stretching back tens of thousands of years. When we think about human ancestry, we often talk about the migrations out of Africa, the genetic mixing across continents, and the influence of powerful civilizations. But what if I told you that, in the heart of North Africa, there exists a genetic legacy so distinct, so unique, that it stands apart from nearly all other populations on Earth? This is the story of Berber DNA, one of the most resilient, mysterious, and ancient genetic blueprints in human history. For centuries, the Berbers, also known as the Amazigh, have lived across North Africa, from Morocco's rugged Atlas Mountains to the vast Saharan dunes. They have witnessed the rise and fall of empires, outlived invaders, and preserved their culture against overwhelming odds. But what makes their DNA so special? To answer that, we need to travel back in time, to an era before history was even recorded, when the first humans roamed the lands that would one day be called North Africa. In Morocco, the discovery of the Jebel Irhoud fossils changed everything we knew about human origins. These remains, dating back over 300,000 years, suggest that Homo sapiens may have had a much more complex evolutionary journey than previously thought. Unlike the commonly accepted narrative that all modern humans descended from a single migration out of East Africa, evidence from North Africa hints at a more interconnected web of early human movement. The ancestors of today's Berbers may be linked to these early humans, their genetic markers forming an unbroken chain stretching back further than almost any other population in the world. Fast forward to 20,000 years ago, and we find the Iberomaurusians, an ancient group that left an undeniable imprint on Berber DNA. Found in caves across North Africa, their genetic makeup shows a blend of early European hunter-gatherers and Near Eastern ancestry, yet they remain distinct from their neighbors. Then came the Capsian culture around 8,000 years ago, introducing Neolithic farming techniques and further shaping the genetic profile of Berbers. However, even after these influences, a core genetic component unique to Berbers, what researchers call the Maghrebi DNA signature, remained intact. But here's what's even more astonishing. Despite the waves of migrations, invasions, and conquests that swept across North Africa, Phoenicians, Romans, Vandals, Arabs, Ottomans, Berber DNA has shown remarkable resistance to being diluted. Unlike other indigenous groups that were genetically absorbed by more dominant cultures, Berbers retained a genetic fingerprint that is still distinct today. Studies of mitochondrial DNA, passed down from mother to child, reveal that the Berber lineage is one of the oldest maternal genetic lines in existence. The U6 haplogroup, found almost exclusively in Berbers, has barely changed for thousands of years. On the paternal side, Berber men carry the M81Y chromosome haplogroup, sometimes called the Berber marker, because it's found at extraordinarily high frequencies among North Africans, yet is almost non-existent elsewhere. This means that, while cultures, languages, and empires may have shifted over time, the biological inheritance of Berbers has remained remarkably stable. This genetic continuity is even more surprising when we consider the Arabization of North Africa. Many assume that North Africans are primarily of Arab descent, but DNA studies tell a different story. Less than 15% of Berber DNA traces back to the Arabian Peninsula, meaning that even after the Arab conquests, the genetic impact was far less significant than the cultural and linguistic shift. The process of Arabization was more about the spread of language and religion than it was about replacing the indigenous population. In fact, many who identify as Arab in North Africa today still carry predominantly Berber DNA. But why did Berber DNA remain so distinct while other populations mixed and changed over time? The answer lies in geography, culture, and social structure. The towering Atlas Mountains and the vast Sahara acted as natural barriers, limiting intermixing with outside groups. Berber tribes, many of whom practiced endogamy, marrying within their own communities, helped preserve their genetic identity. Unlike other regions where conquest meant large-scale intermarriage, the Berbers maintained a strong sense of ethnic continuity. Even today, the uniqueness of Berber DNA remains a subject of fascination. Genetic testing companies are seeing more and more North Africans discovering their deep Berber roots, sometimes without even realizing it. whether in Morocco, Algeria, Tunisia, or Libya. The genetic signature of the Amazigh remains a dominant force in the region. It is a testament to resilience of people who have endured, adapted, and yet, against all odds, preserved a genetic heritage that stretches back to the dawn of humanity. The Berber genetic code is like an ancient manuscript, layered with the imprints of different civilizations, yet still retaining a core identity that has survived for thousands of years. To truly understand why Berber DNA is so unique, we need to look at the different populations that have influenced it over time. Unlike many regions where populations were replaced through conquest, the Berbers absorbed influences while maintaining their distinct genetic blueprint. One of the earliest contributors to Berber DNA were the Iberomaurusians, a mysterious people who thrived in North Africa over 20,000 years ago. Their remains, found in places like Tafrilt, Morocco, reveal genetic links to both ancient Europeans and Near Eastern populations. But here's what's fascinating. Despite their mixed ancestry, they remain genetically distinct, forming the foundation of what we now recognize as the Berber genetic signature. They lived in North Africa for millennia, long before the rise of recorded history, and their DNA is still present in modern Berbers. Then came the Neolithic farmers, who migrated from Anatolia about 7,000 years ago, bringing agriculture, domesticated animals, and new tools. Unlike what happened in Europe, where these early farmers largely replaced hunter-gatherer populations, in North Africa, they mixed with the indigenous people rather than erasing them. DNA evidence shows that modern Berbers still carry significant ancestry from these early Anatolian migrants, but with one major difference: Berber DNA remained dominated by its pre-existing local component. This is a crucial point. While external influences arrived, they never fully replaced the indigenous genetic foundation. The Capsian culture, which emerged around 8,000 years ago, also played a key role in shaping Berber DNA. These were advanced Neolithic people who lived in the Maghreb, likely introducing new tools and social structures. However, unlike the earlier Iberomaurusians, the Capsians had genetic links to populations from the Levant and even parts of East Africa. This could explain why modern Berbers show a small but noticeable genetic connection to sub-Saharan Africa, an influence that would grow stronger in later centuries. But perhaps the most famous ancient influence on Berber DNA came from the Phoenicians. These seafaring traders from the Levant, known for founding Carthage, settled in North Africa around 3,000 years ago. Unlike previous migrations, their impact was more cultural than genetic. DNA studies show that while some Phoenician genes entered the Berber gene pool, their influence was not nearly as dominant as one might expect for such a powerful civilization. The Berbers didn't disappear or get replaced, they adapted and absorbed. The same pattern repeated with the Romans and Vandals. The Romans ruled North Africa for centuries, yet their genetic imprint is relatively minor. The Vandals, a Germanic tribe from modern-day Poland, briefly established a kingdom in North Africa in the 5th century AD, but their genetic legacy is almost non-existent today. This further proves that while North Africa was often invaded, the Berber genetic core remained remarkably stable. However, one major event did leave a lasting mark: the Arab expansion of the 7th century. Many people assume that North Africans are mostly of Arab descent, but genetic studies tell a different story. While the Arab conquest brought language, religion, and political change, it did not drastically alter the genetic makeup of Berbers. The Arabization of North Africa was primarily cultural rather than biological. In fact, modern DNA studies show that most North Africans have less than 15% Arabian Peninsula ancestry, meaning that the Berber genetic foundation remained dominant. One of the most astonishing aspects of Berber DNA is its incredible continuity. Despite countless invasions, migrations, and cultural transformations, the genetic foundation of the Berbers has remained remarkably intact for thousands of years. While many populations around the world were replaced or heavily mixed through conquest, the Berbers managed to preserve their ancestral genetic identity, making them one of the oldest continuous genetic lineages in the world. To understand this genetic resilience, we have to go back 15,000 years to the Iberomaurusians, the earliest known ancestors of the Berbers. Their remains, found in sites like Tafrilt, Morocco, show a genetic profile that is still present in modern Berbers today. Unlike in Europe, where later migrations completely replaced older hunter-gatherer populations, the Iberomaurusians were never fully replaced. Instead, they mixed with later arrivals, creating a unique genetic signature that persisted for millennia. Then, around 7,000 years ago, Neolithic farmers from Anatolia arrived, bringing agriculture and new technologies. But something unusual happened. Unlike in Europe, where Neolithic migrants largely replaced indigenous hunter-gatherers, in North Africa, the two populations merged. DNA studies reveal that modern Berbers still carry Anatolian farmer ancestry, but their primary genetic makeup remained rooted in the original Iberomaurusian populations. This suggests that while new cultures arrived, the Berber genetic structure remained dominant. Fast forward a few thousand years, and we see another example of this remarkable continuity. When the Phoenicians, Romans, and Vandals arrived, they brought major cultural changes, but their genetic impact was surprisingly small. The Phoenicians, for instance, founded Carthage and established trade routes across North Africa. Yet genetic studies show that their DNA contribution to Berber populations was minimal. Similarly, the Romans ruled the region for centuries, but their genetic footprint is barely detectable. Even the Vandals, a Germanic tribe that briefly controlled North Africa in the 5th century, left little to no trace in the Berber genome. The Arab expansion of the 7th century is another key example of how the Berber genetic structure resisted change. Many assume that modern North Africans are mostly of Arab descent, but the genetic evidence tells a different story. While Arabization profoundly influenced language and culture, it did not significantly alter the Berber genetic makeup. In fact, genetic studies reveal that most North Africans have less than 15% Arabian ancestry, with some groups having even less. This means that while the Berbers adopted Islam and the Arabic language, their DNA remained largely unchanged. Even the trans-Saharan slave trade, which brought sub-Saharan African ancestry into North Africa over many centuries, did not drastically alter the genetic core of Berbers. While some regions, especially in the south, show a higher degree of sub-Saharan ancestry, the primary genetic components of Berbers remained largely consistent. The reason behind this extraordinary continuity lies in a combination of geography, culture, and social structure. The rugged mountains and vast deserts of North Africa provided natural barriers that helped Berber groups remain isolated from outside genetic influences. Additionally, traditional Berber societies often practiced endogamy, marrying within their own groups, which further preserved their genetic lineage. This ability to absorb influences without being fundamentally altered is what makes Berber DNA so unique. Despite thousands of years of external pressures, conquests, and migrations, the Berbers have remained genetically distinct. Their DNA tells a story of resilience, adaptation, and an unbroken link to their ancient past, something that few populations in the world can claim. The genetic uniqueness of the Berbers is deeply rooted in prehistory, shaped by some of the oldest human populations ever discovered. Their DNA carries traces of multiple ancient groups, yet it has remained remarkably distinct, resisting full assimilation despite thousands of years of migration and cultural shifts. But what exactly makes Berber DNA so different? The answer lies in the influence of prehistoric populations that contributed to its foundation. One of the most significant contributors to Berber ancestry is the Iberomaurusians, an ancient people who lived in North Africa over 15,000 years ago. They were among the first known human groups to settle the region, and their genetic imprint is still found in modern Berbers today. Their closest known relatives were populations from the Near East, but they also carried a small percentage of DNA that resembles that of sub-Saharan Africans, showing that human movements across the Sahara were happening even in prehistoric times. Unlike many other ancient groups whose genetic traces were erased by later migrations, the Iberomaurusian genetic signature has persisted, making Berbers direct descendants of one of North Africa's earliest inhabitants. Then, during the Neolithic period, 7,000 years ago, another major wave of migration reached North Africa, Anatolian Neolithic farmers. These were some of the first people to practice agriculture, and they spread from the Middle East into both Europe and North Africa. In Europe, their arrival led to the near-complete replacement of local hunter-gatherers. But in North Africa, something unusual happened. Instead of replacing the Iberomaurusians, the Anatolian farmers mixed with them, leading to a unique genetic blend. Modern Berbers still carry Anatolian farmer DNA, but their genetic foundation remains primarily Iberomaurusian, showing that while farming cultures arrived, the indigenous people of North Africa remained dominant. The Capsian culture, 8,000 years ago, also played a key role in shaping Berber DNA. These were Neolithic people who expanded across North Africa, and genetic studies suggest they introduced a West Asian genetic component. However, instead of overwhelming the local Iberomaurusian ancestry, the Capsian migrants blended into the existing populations. This pattern of assimilation rather than replacement continued to define Berber DNA for thousands of years. A fascinating aspect of Berber DNA is that it shows little genetic contribution from the Bronze Age and Iron Age migrants who reshaped many other parts of the world. While Europe and the Middle East saw massive population replacements due to Indo-European migrations, North Africa remained relatively untouched by these events. The Berbers absorbed influences from Mediterranean civilizations such as the Phoenicians, Romans, and Greeks, but their genetic structure was never fully altered. Even the Arab expansion of the 7th century, one of the most significant cultural shifts in North African history, had a surprisingly small genetic impact. While the Berbers adopted Islam and Arabic as a dominant language, their DNA remained largely unchanged, with Arab ancestry making up only a small fraction of their genetic makeup. Ultimately, Berber DNA is a genetic time capsule, preserving the ancestry of some of the oldest human populations in North Africa. The fact that their genetic identity has survived for thousands of years, through migrations, conquests, and cultural shifts, makes it one of the most unique in the world. Their DNA is a direct link to some of the first humans to ever inhabit North Africa, proving that despite external influences, their genetic heritage has remained strong and deeply rooted in prehistory. For thousands of years, the Berbers have maintained a remarkably distinct genetic identity despite living at the crossroads of major civilizations. Their DNA tells the story of a people who, while interacting with different cultures, remained largely unaltered at a genetic level. This genetic continuity is due to a unique combination of isolation, selective assimilation, and deep ancestral roots stretching back to prehistoric times. One of the most striking aspects of Berber DNA is the low level of foreign genetic influence compared to other North African populations. While places like Egypt experienced multiple waves of migration from Europe, the Middle East, and Sub-Saharan Africa, many Berber groups, especially those in the Atlas Mountains, the Sahara, and isolated desert oases, remained largely untouched. Genetic studies show that modern Berbers are direct descendants of North Africa's ancient populations, with very little outside genetic input, even after thousands of years of conquests and migrations. This genetic isolation is particularly evident in certain Berber communities, such as the Mozabites of Algeria, the Tuareg of the Sahara, and the Berbers of the Rif Mountains in Morocco. These groups have lived in geographically challenging environments, such as deserts and mountains, which naturally limited their contact with foreign populations. Unlike urban centers that saw frequent population mixing, these remote regions preserved their genetic identity over millennia. Even major historical events that reshaped other regions had minimal genetic impact on the Berbers. The Phoenicians, Romans, and Byzantines all ruled parts of North Africa at different points in history, yet their genetic imprint is barely detectable in Berber DNA. Similarly, the Arab expansion of the 7th century transformed the region culturally and linguistically, but at a genetic level, it had only a minor effect. This is why genetic studies consistently show that most Berber populations have only 3 to 17% Arabian Peninsula DNA, despite Arabic being widely spoken today. The process of Arabization was largely cultural, not biological. Another key factor that preserved Berber genetic continuity was assortative mating, meaning that Berbers historically tended to marry within their own communities. While many societies saw large-scale intermarriage with foreign populations, Berber groups often maintained strict marriage traditions that kept their gene pool distinct. This pattern can still be seen today, particularly in more isolated Berber-speaking regions. Despite their genetic isolation, Berbers have not remained completely unchanged. They show traces of genetic influence from sub-Saharan Africa, primarily due to the trans-Saharan trade routes that linked North Africa to West Africa for centuries. However, Even this genetic input is relatively small, usually ranging between 5 to 25%, depending on the specific Berber group. It is most pronounced in southern Berber populations, such as the Tuareg, and nearly absent in northern Berber groups, like those from the Rif Mountains. Ultimately, Berber DNA represents one of the strongest examples of genetic continuity in the world. While they have interacted with many civilizations, their core genetic identity remains deeply linked to the ancient populations of North Africa. This is why modern genetic studies still classify Berbers as a distinct population, separate from Arabs, Europeans, and sub-Saharan Africans. Their ability to maintain such a unique and ancient genetic heritage is what makes Berber DNA so extraordinary. The genetic origins of the Berbers stretch deep into prehistory, linking them to some of the earliest known human populations. When we analyze their DNA, we find traces of genetic lineages that predate even the great civilizations of Mesopotamia and Egypt. This deep ancestral connection is what makes Berber DNA so unique. One of the most significant prehistoric populations connected to Berbers is the Iberomaurusians, who lived in North Africa over 15,000 years ago. Genetic studies show that modern Berbers inherit a large portion of their DNA from these early hunter-gatherers, particularly in the Maghreb region. Ancient remains from sites like Tafrilt in Morocco confirm that these people were genetically distinct from both sub-Saharan Africans and Middle Easterners, meaning that the roots of the Berber genome are truly indigenous to North Africa. However, the Berber genetic story doesn't stop with the Iberomaurusians. Around 8,000 years ago, another wave of migration occurred with the arrival of Neolithic farmers from the Near East. These early farmers, related to the Anatolian Neolithic populations who also spread into Europe, brought with them agricultural techniques that transformed life in North Africa. Genetic analysis shows that modern Berbers carry around 40% of their DNA from these Neolithic farmers, especially in the northern regions of Morocco, Algeria, and Tunisia. But unlike in Europe, where Neolithic farmers largely replaced the hunter-gatherer populations, North Africa tells a different story. The Iberomaurusians never disappeared. Instead, they merged with the incoming farmers, creating a hybrid genetic legacy that remains strong in modern Berber groups. This explains why Berbers do not cluster genetically with Europeans or Middle Easterners, despite some shared ancestry. Instead, they form their own distinct genetic group, preserving elements of both early North African hunter-gatherers and later agricultural societies. Interestingly, another ancient genetic contribution to Berbers comes from the Capsian culture, which dominated the Maghreb region between 10,000 and 5,000 years ago. These people introduced new technologies and cultural practices, and their DNA suggests an additional influence from populations of the Eastern Mediterranean and possibly even the Levant. However, despite these contributions, Berber DNA remains overwhelmingly North African in origin, showing only limited gene flow from outside sources. What's fascinating is how these prehistoric genetic layers still define Berber populations today. While other North African groups, such as Egyptian Arabs, show significant genetic mixing with sub-Saharan Africans and Middle Easterners, Berber groups have preserved a much older genetic identity. Their DNA is like a time capsule, reflecting thousands of years of human history in the Maghreb. This is why geneticists consider Berbers to be one of the most ancient and continuous populations in the world. Their DNA connects them to some of the earliest human societies, making them a living link to North Africa's deep prehistoric past. Throughout history, North Africa has been a crossroads for civilizations, traders, and conquerors. From the Phoenicians and Romans to the Arabs and Ottomans, countless groups have passed through the Maghreb. Yet, despite these influences, Berber DNA remains distinct, preserving an ancient North African identity that has survived for thousands of years. But how did these civilizations impact their genetic makeup? The Phoenicians, known for their vast trading empire, arrived in North Africa around 900 BCE, founding cities like Carthage. These seafaring traders from the Levant left their mark on the region, but interestingly, their genetic impact on Berbers is relatively small. DNA analysis shows that although Phoenicians introduced cultural and economic changes, they did not significantly alter the Berber genetic landscape. Instead, they blended into the local population without replacing it. A greater genetic shift occurred with the arrival of the Romans in 146 BCE. The Roman Empire stretched across the Mediterranean, and North Africa became a key province, supplying grain and other goods. Many Romans settled in the region, and we can see traces of Southern European DNA in some North African populations today, particularly in Tunisia and northern Algeria. However, just like the Phoenicians, the Romans did not erase Berber ancestry. Instead, they intermarried with the local people, contributing small amounts of European genetic material, while Berber identity remained strong. The Vandals, a Germanic tribe that invaded North Africa after the fall of Rome, ruled from 429 to 534 CE. Although they established a kingdom, their genetic impact was minimal. Unlike the Romans, who settled in large numbers, the Vandals were a smaller warrior elite. This is why genetic traces of Germanic ancestry are almost non-existent in modern Berbers, despite the Vandals' historical presence. The biggest demographic shift came with the Arab expansion in the 7th century CE. The Arab conquest introduced Islam and the Arabic language, leading to the cultural Arabization of North Africa. However, when it comes to DNA, the story is more complex. While some Berber groups, particularly in coastal cities, absorbed Arab genetic influences, many Berber populations remain genetically distinct. For example, studies show that modern Berbers have only around 3 to 17% Arabian Peninsula DNA, meaning that despite adopting Arab identity, their genetic roots remain overwhelmingly North African. One of the most fascinating aspects of Berber DNA is its resistance to genetic replacement. Unlike many other regions of the world, where conquerors left a dominant genetic imprint, Berbers absorbed foreign influences without losing their core ancestry. This suggests that even as cultures changed, the Berber people remained rooted in their indigenous genetic heritage. This is why Berber DNA is so unique. It has survived thousands of years of migrations and conquests while preserving an ancient lineage that connects directly to North Africa's prehistoric past. Despite centuries of migrations, conquests, and cultural transformations, Berber DNA has left an undeniable imprint on modern populations, not just in North Africa, but across the Mediterranean and beyond. But where do we see the strongest traces of this legacy today? One of the most obvious places is Morocco, Algeria, Tunisia, and Libya, where Berbers continue to form a significant portion of the population. Genetic studies show that even among those who identify as Arab, the majority still carry predominantly Berber ancestry, proving that cultural shifts did not erase genetic heritage. For instance, a Moroccan who speaks Arabic may still have DNA that connects directly to the ancient Berbers of the Atlas Mountains. But Berber DNA is not limited to North Africa. The Canary Islands hold one of the strongest genetic connections to the ancient Berbers. The indigenous Guanches, who lived on the islands before Spanish colonization, were directly descended from North African Berbers. Although Spanish settlers arrived in the 15th century, modern genetic studies show that Guanche DNA still survives in the Canary Islands population today, making it a living remnant of ancient Berber expansion. Moving across the Mediterranean, southern Europe, especially Spain, Sicily, and southern Italy, also carries traces of Berber ancestry. During the Islamic rule of Spain Al-Andalus, from 711 to 1492, North African Berbers played a significant role in governance and military campaigns. Many Berbers settled in Spain, and when the Christian Reconquista expelled Muslims, a significant portion of them fled back to North Africa. However, their genetic footprint remained. In fact, modern genetic studies reveal that many Spaniards, particularly in the south, carry a small percentage of North African DNA, directly linked to Berber ancestry. Similarly, Berber DNA is found in sub-Saharan Africa, particularly in Mali, Niger, and Chad. This is largely due to the trans-Saharan trade routes, which facilitated not only the exchange of goods, but also the movement of people. The Tuareg, a nomadic Berber group, still live in the Sahara today and have retained a genetic signature that links them to both North Africa and parts of sub-Saharan Africa. Even in the Middle East, Berber genetic traces can be found due to historical interactions with Arab and Ottoman empires. Though less prominent than in Europe or sub-Saharan Africa, there are small genetic links that reflect centuries of migrations, trade, and alliances. The spread of Berber DNA across these regions highlights one key fact. The Berber legacy is not confined to North Africa, It is global, from Europe to the Sahara, and even across the Atlantic in places like the Canary Islands. The genetic imprint of the Berbers remains a living testament to their resilience, mobility, and deep historical roots.